Alright guys, I'm going to be showing y'all how to use this atom building thing here, and it's a Bohr model, and as you can see in the center we have the nucleus. That's where the protons and the neutrons are going to go. Around the nucleus we see the electron cloud, and that's where the electrons are going to go. We are going to use marbles to represent our subatomic particles. Subatomic particles means protons, neutrons, and electrons. So here are our marbles we're going to use, and they're different colors. So you just have to remember that. Protons are red, neutrons are blue, electrons are yellow, and I love you. Sorry, I just thought that rhymed and it sounded good. So protons red, neutrons blue, and electrons are yellow. Got it? Okay. So to do this, what you're going to need is you're going to need your periodic table. Remember, it's a tool that chemists use. You're going to need your periodic table. You're also going to need some paper that you can draw Bohr models on. Okay, so let's look at our Bohr model thing here. Remember, the nucleus is in the middle, and the electrons are going to go on the outside. The first element we're going to do hydrogen. And as you can see, hydrogen right here has an atomic number of 1. All right. It has a mass number of 1. So that means it's going to have 1 proton, and the total number of things in a nucleus is going to be 1. So that means 1 proton and no neutrons. We're going to do an atom, so it's going to have the same number of protons as electrons. So all we need here is 1 proton and 1 electron. And here's my proton, and here's my electron. The thing I forgot to mention about the electrons is electrons are going to fill from the lowest energy level to the highest energy level. Okay? So in other words, we have to fill in this. I don't know if y'all can see, but it says number 1 here. 2, 3, 4, 5. This is the first energy level, and we have to fill the first energy level before we can go to the second energy level. We have to fill the second energy level before we can go to the third, and so on and so forth. That's how electrons fill in. So, if we look at our Bohr model would look like this. And there's our hydrogen atom, and it has 1 proton and 1 neutron. Okay, so now we're going to do helium. Okay, so let's look at helium on the periodic table. And helium on the periodic table, well, it's got an atomic number of 2. So it's going to have 2 protons. But its mass number is going to be 4. If we take 4.003, we round that off to the nearest whole number. That's going to be 4. So in other words, there's going to be 4 marbles, or 4 protons and neutrons in the nucleus. 2 of them are going to be protons, so 2 of them are going to be neutrons. We're also going to have 2 electrons because this is an atom. So I'm going to add a proton, and put 2 neutrons in there. And I'm going to add another electron. Remember, we add the electrons. Now the first energy level is full. And if we look at here is our Bohr diagram. We can see 2 protons, 2 neutrons. We know that the mass number is 4. And since the first energy level only holds 2 electrons, it's now full. If it has a full outer shell, that means it's a noble gas. It's not going to react with other elements. All right, let's go on to carbon. So now we're going to make carbon. And there's carbon on our periodic table. Carbon has 6 protons, 6 neutrons, and 6 electrons. We see that the atomic number is 6. Mass number is 12. So that means it's 6 protons, 6 neutrons. And we're talking about an atom, so it's going to have the same number of protons as neutrons. So let's get our protons and neutrons in there. There's my 6 protons. And there's my 6 neutrons. So now I'm going to add 4 more electrons. And since the first energy level is full, I'm going to start putting them out here in the second energy level. All right, do you see how many electrons are in the outer shell of the carbon atom? Remember, outer shell electrons are called valence electrons. And how many are there? 1, 2, 3, 4. So carbon has 4 valence electrons. Now let's look at it on the periodic table. And look what group it's in. It's in group 14, or 4A. That tells me how many valence electrons it'll have. If you look at the numbers that have the A next to them, that will tell you how many valence electrons they have. Nitrogen will have 5 valence electrons. Oxygen will have 6, fluorine 7, and all of these except for helium will have 8 valence electrons. Over here, group 1 will have 1 valence electron. Group 2 will have 2 valence electrons. Don't worry about all of these in the middle, the crazy ones, the transition metals. We're going to talk about those later. All right, let's build another atom. Let's look at the fluorine atom. All right, so let's look at our periodic table, figure out how many protons, neutrons, and electrons we're going to have. All right, so we look at fluorine. How many protons should it have? That's right, 9. And what's the mass number? Well, let's round 18.998 to the nearest whole number. 18.998 is 19. And what is 19 minus 9? That's right, it's 10. So we're going to have 10 neutrons, 9 protons, 9 neutrons. And since we're building an atom, it's going to have 9 electrons as well. All right, let's put the marbles on. Okay, so I already have 6 on there, so I need to add 3 more protons. Now I have 9 protons. There are 10 neutrons. All right, now I'm going to have 5 more electrons on here. Okay, so I'm going to start filling in the second energy level. 1, 2, 3. Okay, so now I've got 2 in the first energy level. 1, 2, 3, 4, 5, 6, 7 in the second energy level. I have 7 electrons out here in the outer shell. Remember, those are valence electrons. So fluorine has 7 valence electrons. Look at the periodic table. Oh my gosh, it's in group 17, or 7A. That's amazing. Now, fluorine wants to be like a noble gas. All the elements want to be like noble gases. They all want to have full outer shells. But if you look, can you see? It just needs 1 more electron. 1 more electron. You see this open spot right there? If it had 1 more electron, it would have a full outer shell. So what fluorine's going to do, fluorine's going to add an electron. Think about electrons, they're just all over the place. So it's easy to pick up an electron here or there. So now it has a full outer shell. But wait a minute. We did not change the number of protons, did we? So here's what the fluorine atom looks like. Okay, so here's our fluorine atom. okay, with its 9 protons and 9 electrons, and that's going to be neutral. That equals 0, no charge, right? Okay, but we're going to add an electron. Okay, you see the one in red there? That's the one we added. Okay, but see, here's something that's going to happen. When we add that one electron, now we have 9 protons and 10 electrons. Protons are positive, electrons are negative. So 9 minus 10, well, that equals -1. So when fluorine picks up an electron, it forms a -1 ion. That's why we are going to write -1 above group 17. Okay? Because every element in group 17 or 7A, fluorine, chlorine, bromine, iodine, they're all going to have 7 valence electrons. They're all going to want to gain 1 electron to form a -1 ion. Awesome, isn't that? Okay, let's look at something else. Let's look at sodium. All right, so if we were to look at sodium on our periodic table, let's figure out how many protons and neutrons we want to draw for that. Okay, sodium has an atomic number of 11. So how many protons? That's right, 11. We're going to do 11 protons. We look at the atomic mass, it's 22.990. If we're going to round that off to the nearest whole number, that would be, you got it, 23. So our mass number is going to be 23. And what is 23 minus 11? Good, that's 12. So we're going to have 11 protons and 12 neutrons. Now we're building an atom, so we're going to have 11 electrons, so we have the same number of positive charges as negative charges. Remember, atoms are neutral. Okay, so I need to add 2 more protons, because we have 9 there. And there's, oh, that's a neutron. 10, 11. And I need to add, let's say I've got 10 neutrons there. I need to add 2 more neutrons. There, now I've got 12 neutrons. Now let's fix our electrons, okay? So we've got 9 on there. No, we have 10 on there now because we gained 1. So I just need to put 1 more electron. So I'll put my 1 electron here. Now remember what I said, that atoms want to have a full outer shell of electrons. So sodium could add, oh I'm sorry, out of focus there. Sodium could add 7 more electrons, right? I could go get some more marbles. Tons of marbles right here. And I could add, 1, 2, get back here, 3, 4, oh, problem, those are supposed to be there, 5, 6, 7. Now I've got a full outer shell. But you know what? Atoms like to do things that make it easier. So what would be easier than adding those 7? I'll show you. So we got this 1 valence electron there. By the way, if you have 1 valence electron, what group are you in? There's sodium. What group is sodium in? That's right, it's in group 1. You have 1 valence electron. Okay, you have 1 valence electron. What happens if you just get rid of that 1 electron? So we're going to lose this electron. Now sodium has a full outer shell. It goes down to the 2nd energy level. It has 10 electrons, just like neon. So it wants to be like neon now. All right, so here's what happened. All right, so here is our sodium atom with its 11 protons and 11 electrons. And of course, it's going to be neutral. So it's got 2 electrons in the first, 8 in the second, and the 1 valence electron in the third. By the way, notice it has 1 valence electron in the third energy level. Look where it is on the periodic table. It's in group 1, period 3. I wonder if that means anything. So we look at our sodium atom, okay? Now this is showing you we could add those 7 electrons, but that'd be really hard. But what we're going to do is we're going to take that 1 electron away, okay? We take that 1 electron away, and now we have our sodium ion. Here's our sodium ion. It has 11 protons and 10 electrons. And 11 minus 10 is positive 1. So sodium is going to form a +1 ion. Okay? It's going to have the same electron configuration as neon. There's neon. And neon's a noble gas. So in other words, the elements want to have electrons just like the noble gases. And if we look, this tells us here, all of the elements in period 1 are going to lose 1 electron and form a +1 ion. That's why we write +1 on there. All right, so now let's do magnesium, okay? So we look at magnesium right here. We see we're going to need 12 protons. The mass number is 24, because we round that off to the nearest whole number. So 24 minus 12 is, that's right, 12. So 12 protons and 12 neutrons. And we're going to have the same number of electrons, right? So 12 electrons. All right. So let's look at our board here. We've already got 12 neutrons on there. So really all we have to do is add 1 more proton. Now our nucleus is good. We've got our 12 protons and 12 neutrons. Now let's look at our electrons. We have 2 in the first, we have 8 in the second, and we're going to put 2 in the third. Now we have 12. Okay, so when we fill this up from the lowest part going up, we fill up the first, we fill up the second, and there's 2 in the third. Look where magnesium is on the periodic table. It is in the third period, group 2. This tells you it's got 2 valence electrons in the third energy level. Now look at the board. Do you see the 2 valence electrons? Right here and right there. Those are the 2 valence electrons. Now, magnesium, like sodium, wants to have a full outer shell. Now, magnesium could add 6 more electrons, but it'd be real easy for it just to lose those 2. All right? So when it loses those 2, now it has 12 protons and 10 electrons. So here's our magnesium atom with its 2 valence electrons in the third energy level. And here is the magnesium ion with its 10 electrons. 12 minus 10, that means +2. In fact, all of the elements in group 2, beryllium, magnesium, calcium, strontium, barium, and radium, they are all going to form +2 ions. They all have 2 valence electrons. They will lose 2 valence electrons to form a +2 ion. Okay? So one of the main things you want to get out of this is metals lose electrons to form positive ions. Nonmetals gain electrons and form negative ions. Okay? That's a big picture kind of thing, big idea. Make sure you wrap your brain around that. Okay, so now we're going to look at trends for reactivity. All right, so I'm going to go back to sodium. All right, so I need 11 protons and 12 neutrons. We're good there. All right, and we're going to have our one valence electron there. Okay, so there's sodium. Now that one valence electron, remember it's negatively charged. Negative, positive, they attract each other. So the electrons are held in place by the positive charge of the nucleus. All right, so it takes energy to remove an electron. So how hard do you think it would be to remove an electron from there versus, let's say, we did lithium. Lithium has 3 protons. And it has 4 neutrons. And 3 electrons. All right, so here's our valence electron. It's in the second energy level. It takes a lot more energy to remove that electron from the second energy level. If we were talking about rubidium, rubidium is way out here in the 5th energy level. Okay, so that valence electron would be way out here. If the valence electron is that far from the nucleus's hold on it is not as strong. This electron will leave rubidium so much easier than lithium. A lot easier. So therefore, rubidium is more reactive. In other words, it reacts more easily because it's easier to remove an electron that's very far away from the nucleus. So when we look at our periodic table, as we go, this is for metals, by the way, as we go down the periodic table, reactivity is going to increase. So what I want you to do is I want you to draw an arrow going down. Like that. And next to that arrow, I want you to write reactivity for metals increases. Like that. So you want to have an arrow on the left side of your periodic table pointing down saying reactivity for metals increases. All right? Remember, that's for metals. It's going to be different for nonmetals. Now, what is the trend for reactivity as we go this way across the period? Well, let's think about this, okay? Let's go back to sodium and magnesium. I'm not going to bother with the nucleus. I'm just going to bother with the electrons now. All right? So, sodium has 1 in the 3rd. So I got my first energy levels full. My second energy level is now full. And there's my 1 in the 3rd. Now, remember it takes energy to remove an electron. So there's 1 electron. That's going to take energy. Now there's 2. Which one do you think it would be easier? Is it easier to remove 1 electron or 2? That's right. It's easier to remove 1 electron than 2. So therefore, sodium is more reactive than magnesium. So as we look at our periodic table, here we go. Sodium is more reactive than magnesium. So reactivity increases as we go to the left for metals. So we're going to draw an arrow down here at the bottom, going to the left, saying reactivity for metals increases. All right, so there we go. So reactivity for metals increases as you go to the left and down. So in other words, what would be the most reactive metal? That's right, francium. Francium is the furthest down and the furthest to the left. So francium is the most reactive metal. As we go this way, all these transition metals, they are not as reactive as group 1 and 2. In fact, groups 1 and 2 are oftentimes referred to as the active metals because they're very reactive. So as you can see right here, zinc is less reactive than copper. Copper is more reactive than nickel. Okay? Now, some of these get kind of weird because like gold is not very reactive at all. That's why we like to use it in jewelry because it doesn't tarnish. Gold and silver don't react very well. But in these other groups, reactivity is going to increase as we go down the group. Okay? Now let's look at the non-metal side. All right? So I'm just going to look at the electrons. Don't worry about the nucleus. Let's look at the electrons. So let's go to fluorine. Fluorine has 9 electrons. So here we go. Fluorine has 9 electrons. Okay, so fluorine wants to add an electron right here. And remember, the positive charge of the nucleus holds electrons in. And so the positive charge, the pull, is very strong here on the second energy level. If we were to look at something like, let's see, who's on the 5th period there? Let's go to the 4th period. Bromine. So bromine has 1 on the 4th energy level. So bromine wants to add 1 way out here. Okay? Is the pull from the nucleus going to be as strong out here in the 4th energy level as it is on the 2nd? No. So electrons are going to be added much more easily to fluorine than to bromine. Therefore, when we look here at our periodic table, we're going to look at group 17. It's easier to gain an electron here in the 2nd energy level than it is way out in the 4th or the 5th or the 6th or the 7th. So reactivity is going to increase as you go up the group. Okay? So fluorine is the most reactive nonmetal because it's at the top. Okay, so we're going to draw an arrow on this side going up, saying reactivity for nonmetals increases. All right. Oh, I spilled all my electrons. Okay, so there's our trend on the groups for reactivity of the nonmetals. Now, as you can guess, just like we were talking about with the metals, is it easier to gain 1 electron or 2? That's right, it's easier to do 1 electron. So fluorine is going to gain 1 electron, and oxygen is going to gain 2. So fluorine is going to be more reactive than oxygen. It's easier to gain 1 electron than to gain 2. So we're going to draw an arrow on the bottom here, going this way to the right, showing us the reactivity trend across the period, back and forth, horizontal, for nonmetals. So there's our arrow showing to the right. So up and right is reactivity for nonmetals. So the most reactive nonmetal is fluorine. See there? And of course, down the other side, francium. And francium would be our most reactive metal. So now we can compare two metals and we can say, hey, which one is going to be the most reactive? For example, if I compare beryllium to strontium, which one is going to be more reactive? That's right, strontium, because strontium is below beryllium and reactivity increases as you go down the period. Okay, what about strontium and rubidium? That's right, rubidium. Rubidium is going to be more reactive than strontium because it's easier to lose one electron than two. Okay, and beryllium, it's easier to lose the electron down here on the fifth energy level than the second. That's why strontium is more reactive than beryllium. Okay, so let's look over here. What about if we compared oxygen to sulfur? Which is more reactive? That's right, oxygen, because oxygen is above sulfur. It is easier to gain an electron in the second energy level than the third. Okay, what about phosphorus or sulfur? Which one would be more reactive? That's right, sulfur, because sulfur is going to gain 2 electrons, whereas phosphorus has to gain 3. Easier to gain 2 than to gain 3. So that's how the game is played, folks. Let me know if you have any questions. And there's going to be a quiz over which metal is more reactive. And use what you've learned in this video to help you out. And does anyone want to help me pick up all the marbles? No? All right. See you later.